Hello, everyone. Welcome to the Surgex enVision User Group webinar. My name is Vince Luciani. I am the Senior Sales Engineer here at Surgex, and welcome to today's webinar about the enVision and great ways to use it. I have been with Surgex for about a year now, and I've met some of you at Infocom or at CEDIA or maybe at your office. A quick shout out to CCS in Nashua, who I am up here in the Boston area visiting. For those of you who I have not yet met, my role at Surgex is to travel with our sales team and help them spread the good word about Surgex, as well as provide support to our dealers. That support comes in the form of helping you guys create a solid power foundation for your systems by assisting you in planning your power strategy on a project. If you ever have any questions on which Surgex products to spec in, please feel free to reach out to me directly or through your sales representative. Along those same lines, I am responsible for conducting these webinars. Today's webinar is the enVision Users Group. We are going to talk about how to install, how to set up, how to collect and interpret data that is gathered by the enVision tool. I have a couple of guests today. First up, Jimmy Patchke is the National Sales Manager for Residential Applications here at Surgex. If you have not yet met Jimmy, you are in for a treat. He's not only quite knowledgeable about all things Surgex and enVision in particular, but also plays a mean set of drums. Hello, Jimmy.
Hello.
Also, we have Surgex Director of Engineering, Research, and Development, Rob Dolly, on the line. Rob is responsible for our extensive product line and is personally responsible for the enVision product. And from what I understand, he's a shredder. I'm looking forward to getting together with Rob someday and shredding some guitar. Say hello, Rob.
Hey, everybody.
So it's great to have both of you with us today. Before we get started, I want to make you all aware of webinars we have completed thus far. We have webinars scheduled on the third Thursday of every month at this same time, 11:30 Eastern, 8:30 Pacific time, AM. As you can see from this graphic here, we have covered some important topics. If you'd like to view these webinars, I'm showing a link up there on the page on Go to Stage. If you don't want to write this link down, you can always check with your Surgex sales representative and they can email you that link. On this link, you will not only find our webinars, but some interesting videos as well. So we are here today to talk about the enVision. I get a question sometimes on the branding. So this device is from our sister brand, ESP. We have been selling the ESP enVision product into the office equipment, office automation market since about 2002. I'm sorry, 2012. We've made it available to our Surgex dealers in 2014. It has a great track record, and it's not a stagnant product. It's been updated over the years, thanks to Rob's great work there. So what is the enVision? The enVision is a cost-effective power analysis tool that you can just plug in and leave it in place. It keeps a historical record of the voltage levels and the power usage over time, as well as timestamp when power disturbances occur. You can measure electrical parameters in real time. It has an oscilloscope functionality that we will be demonstrating shortly. It dates and timestamps up to 512 electrical disturbances, such as surges and power outages and overvoltage, undervoltages. It keeps track of neutral to ground voltage issues. It keeps 138 days worth of voltage and power data. So, you know, what does this mean to you? This allows the techs to pull up in real time the power reports and prove to the clients that the issues such as power outages or voltage fluctuations have occurred and that it's not your equipment that's the issue. So it's a great tool for getting that monkey off your back that you know, when it's not really your equipment that's the issue. It's also a great tool for specifying UPSs. You can measure the current draw or the power draw of an entire rack or a piece of equipment and make sure you are sizing your UPS correctly. So Jimmy, let's get you into the conversation here. We want to talk about when and where to use the enVision tool. So you know, when you talk to your dealers, how do you address that?
Well, I can tell you, it's also been a changing evolution of utilization. So back in 2014 and part of 15, I think dealers were finding themselves very frustrated in situations where they suspected they may have a power issue. But you know, the electrician that came on site, he'd say, well, you know, the lights are on, I've got 120. And then it's like, well, shoot, maybe it's a product issue. Maybe I did my programming or the installation wrong, or so they chase and chase after this particular ghost, and it was always reactive. And so as guys found that they had power issues, I think they started to utilize enVision even more. And they tried to become more proactive in their approach, meaning checking out the power ahead of the installation's completion. Or
Exactly.
taking a bookmark, a benchmark reference point, maybe a month during the initial installation. So they always had that reference point on record to refer back to 6 months, a year down the road. And then lastly, leaving it on job sites that are hard to get to. Maybe you've got to take a flight somewhere to get to a job site, or it's a long drive, half a day, you know, spent just to go out and find out we've got a power issue, not a product issue. Customers that are high profile, maybe you want to make sure that you give them the best level of service. That could be a VIP of any type, or neighborhoods that are just known for power problems. It's great to leave enVision on site, though.
Yeah, I mean, Jimmy, I tell my the guys I talk to the same thing. You know, before installation, you know, it lets you know before you get there if you've got power issues, and in some cases, it has opened up the conversation in two different ways. Either you can tell the end customer, we need to get an electrician in here to clean up the power situation before I install my equipment, and you get, you know, mad at me, or it opens up the conversation to, hey, I need to put a double conversion on UPS. Your power is so unstable, and you're in an office building, and you have no control over you know, changing it, or maybe you're in a residential area and you've got no you know, the ability to improve the power. So now, you know, I'm sorry, but we're going to have to you know, increase the bill of materials to include an online double conversion UPS to get rid of these power fluctuations. So I think it's a great tool for before. And then, you know, for me, on after, it's an insurance policy. You know, you never know. The one thing that I think gets lost about our power generation and distribution system is that power is generated at the time of use. So, you know, right now everybody's using electricity. The electricity you're using is being generated milliseconds ago at a power plant near you somewhere and being distributed. So the track record that happened in the past is in the past, and a lot of times a power fluctuation or a power issue will occur, and then it doesn't come back, and then your equipment is blamed, you know, for an issue, and now you have a record of it. You know, you might go to the site you know, a couple of days later, and you know, you might, if you were to stick a meter in at that point, it's like, well, the power looks great, yeah, but 2 days ago when you had the problem, you need to have a record of it. And it's, Jimmy, it's not a very expensive tool, so it's something that that our dealers can purchase for every job and just keep it on site.
Yeah, absolutely.
So installation, it's really simple. You just plug it in, and you know, I like to plug it in adjacent to your rack equipment. You know, often there's a duplex outlet there, and your rack strip is plugged into one. You can plug the enVision into the other outlet. The enVision actually has outputs on it as well. And you know, when we sell the enVision on the office equipment side, it's actually a power protection device. It does have multi-stage, or you know, what we call our multi-stage hybrid power protection. It's MOV and gas tube hybrid design, so it takes away some of the detriments and some of the shortcomings that you get with MOV technology. It's not advanced series mode, but it does have a little power protection in it. But you can connect it in series and get load information, power consumption, and current consumption if you want. But you don't have to have a load connected. You can just plug it in directly to the wall. So the two ways of interfacing the enVision to either change or set parameters or to download data, you know, there's two ways of doing it. First way is to use your PC on site, and we supply you with a USB to RJ25 cable. It goes into the data port of the enVision device. you will need to download and install our PC app that is available free from the Surgex website. The second way you can see on the right side of the page is to connect it using the enVision tool, and I'm sorry, connect the enVision tool using the Rpip. The Rpip is an external adapter that interfaces with the data port of the enVision and provides network access via an Ethernet jack. Here's a picture from one of our dealers. Jimmy, who was this? Was this that gave us this install picture? Jimmy, you there? Anyway, I believe it was NXT out in Newport Beach.
Yeah, Ellie at Next AV did a great job on that.
Yeah, that's right. All right, Jimmy's back with us. With the Rpip, you can perform all the same functions you could if you've got your local PC there, but you're doing it from your office or a remote location. And a lot of you may not be aware, but there's also an Android app for connecting to a system. Rob, can you tell me real quick what are the requirements? Do they need? Do they need a special adapter? Is that correct? USB adapter?
Yes, you'll need a Android device, phone or tablet that supports USB on the go, which most of them do nowadays. As long as you have a plan, the only ones that don't are like the Go phone kind of things. So it just has to be an unlocked one or one with a plan. A little USB on the go adapter, you can pick them up various places, and our regular, what we call our USB interface cable that connects to the product. So if you have the USB cable, you can connect it to your laptop or to an Android device and use the mobile app. Either one. So that's just on the Google Play Store, and it's got pretty much all the same features and functionality as the desktop software.
Yeah, that was a pretty cool feature that I think that not a lot of people know about. And again, the little dongle just goes in line with the USB, and that allows you to plug it into your phone. So it's pretty cool. So in a few minutes, we will be bringing up a real enVision and showing you a demo of the real enVision. But for now, I just wanted to show you a couple of screenshots of the setup menu. And Rob, you can chime in here as you wish on suggested setup. But if you go to the setup tab, which is this little gear icon here, this allows you to sync the clock. Now the clock is set at the factory, and maybe in a different time zone than you are. So it's a good practice to go in and adjust the clock. You could either set it manually or hit the auto set, and it syncs up with the clock in your PC. The other thing that I like to do, and Rob, you may want to comment.
Hey, Vince, if you have 1 second there, sorry to interrupt. I would recommend setting the clock, doing the auto set clock. Anytime you have it back in your office before you deploy it again, because there is a little bit of drift with the clock, so it's good to always just reset it whenever you're able before you deploy it, just to minimize that.
Yeah, I think it's a great idea, and I like to activate the internal chart mode. That just allows the enVision. This is one of the improvements that Rob has made along the way on the newer versions, that you have this internal chart mode that keeps that data or that collects more data than the regular historical data mode. So that's a good practice to go ahead and do that.
Vince, and when we're going through showing the actual operation of the software with a live unit, when we get to the chart mode example, I'll kind of explain the difference between what we're seeing live on the screen and what that internal chart mode does, because they're similar, but they're a little bit different to make sure everybody understands what's what. Very good,
very good. And finally, if you go to the data tab, one thing you may want to do is erase the data. Now I know that traditionally people kind of revere this tool, and they think that it's it's like, oh yeah, I just want to have this as a tool for the guys in the to put in their service vans and use it as needed. If you're going to be using that and moving it around, you want to, it's a good idea to erase the data. It's not the end of the world. Sometimes I've received a data set and it's clear that the unit was unplugged and it was offline for a couple of months and then plugged back in. But you can always erase your data. But again, I really suggest that you keep these things on site. because again, they're very cost-effective tools. They're not very expensive, and they're great to just leave on site. So depending on if you're using the PC app or the Rpip, the user interface graphics look a bit different, and you can see here the difference between the two. However, all the controls are basically the same. Is that right, Rob?
Yes, the controls and kind of the general layout and operational modes are basically the same. It's just, the web interface through the remote portal is JavaScript based, and the PC app, of course, is, like Windows form-based kind of thing. So a little bit, some differences. If you're comfortable with one, it should be no problem to use the other. And the saved data files, the format is compatible from the remote portal with the Windows application, so you could save them from the remote portal and then load them back into the Windows app later.
Very good, very good. All right, so now we're going to go switch over and do a look at the live view of the enVision that I've got here on my disk. When you plug an enVision in and you start the app, you may find that especially if your computer, if your laptop is kind of an enterprise type computer, given to you by a big company, you may have to run it using administrator rights. So that's a common issue that people have. You need to make sure that you're administrator. So you do that, and then you go over here to the settings icon and go over and click it twice and hit to the COM port setup. I've already done this. You hit this detect button, and that will set up your USB port and get you going. And I've already done that. So here I am looking at the power real time of what's coming in at the wonderful Courtyard Inn in sunny downtown Boston. So you can see our line voltage here is 100, 119 near 120. I get the question a lot, what's a good voltage? Voltage, nominal voltages change a little bit depending on your area of the country, but a lot of standards boards say between 110 and 124 is a good number. I know the voltage at my house seems to be 122 all the time, or not all the time. It fluctuates. Voltage fluctuates. I think that's one thing when you start messing around with one of these tools and have it going all day long, like Rob and I do. You find out that voltage is not stable, but it goes all over the place. So I happen to have on my enVision the power supply to my computer on here, and looks like I'm pulling just shy of a half an amp, about 28 watts. This fourth item right here is the neutral to ground voltage. So as you can see, this is a good use of the enVision tool. Sometimes you can go on site, your enVision tool there, you plug either your PC into it or as we found out today, your Android phone, and you can look at the neutral to ground voltage. And this is an indication of sometimes you have problems, and it's due to having a high neutral to ground voltage. Less than a quarter volt is probably good. If you're above 1.5 volts, it could be a problem. Different equipment react differently to neutral to ground voltages.
And on that note, I want to mention that the voltage we're looking at here is the 60 hertz power line frequency neutral to ground voltage. Our products will act to filter out a lot of the high frequency neutral ground voltage content, and this measurement here is really the 60 hertz. And like Vince said, a high value. And if anybody wants more details, please get in touch with Vince or myself later for acceptable ranges and things. But a high value could indicate various things. The most common would be like excessive loading of the circuit. Another thing could be like something miswired or a bad connection or loose connection requiring an electrician to kind of chase down and correct. But I just wanted to make that comment on the neutral ground voltage.
Very good. So the fifth one down here is your line frequency. The next one down, the PF, that is the power factor. Now the power factor is really a measurement of and is reflective of the load device. So it's really not an indication of the power quality coming in. It's really more of an indication of the load. And if you want some more information on power factor and this last one, crest factor, and what's the difference of them, We do have a white paper that is available on our website that goes into detail, excruciating detail. I know it's excruciating because I wrote the white paper and I couldn't believe how much I wrote on the difference between power factor and crest factor. But for our purposes today, this is really not anything that you have to deal with. It's just kind of a nice to know, what your load's going on. Crest factor is a numerical indication of the harmonic quality of the sine wave coming in. So, one way to look at the quality of the sine wave is to go over here to the oscilloscope mode and see this white here is actually the oscilloscope representation of the AC power coming in. So when you have a crest factor of 1.41, what it means is that your sine wave is peaking up to where it should be, right? But sometimes when you go over here and you find your crest factor to be lower, it's an indication that you might have some clipping of the waveform.
Hey Vince, will you do me a favor and click the channel 2 button off? And you should see that the sine wave looks a little bit smoother. That's because our effective bandwidth on this built-in oscilloscope feature is about 4 kilohertz, right? So it's not as good as the $10,000 Tektronix scope we have here in the lab or anything. But if you do the individual channels, and then likewise, Vince, if you'll turn channel 1 off and turn channel 2 on by itself, and you want greater resolution looking at voltage or current by itself, that's what I would recommend. But then if you click them both on, you'll see that now the bandwidth is shared between the two, and that's why the shape is, it's just the way that I'm doing like the connecting the dots, as it were, here, right?
Okay,
So
gotcha.
for higher resolution, just look at them independently.
Independently, good. That's a good tip. So one of the things you can see here, as far as the current draw is concerned, is that my little power supply on my laptop computer here does not pull current in a sinusoidal fashion like the AC voltage is. It only pulls current at the peak. So as you can imagine, if I'm pulling current only at the peak, and if I have a long wire run where I'm being restricted by when current flow happens, that could cause the top of this waveform to get chopped off. Only at the top. It's not like the whole waveform is reduced in amplitude. It's just the top gets chopped off. And when you get that chopping off, that's when your crest factor will go down to the ones and the 1.2s. So so again, this is a numerical representation, and you can see it. So what can you do if you've got that? Well, if you've got like a low crest factor, that's an indication that the wire size may be small, and that you've got these kind of impulse type of loads. So
hey Vince,
yeah?
I want to make a comment on that, and I think this is something that gets kind of missed a lot of times, right? Let's say that a lot of your big equipment that has switch mode power supplies will have what's called power factor correction built in, where the current draw is more sinusoidal and follows the voltage waveform and is not as much like this where it's only pulling in the center at the peaks. But if, let's say you have a rack with a bunch of smaller gear and it's all pulling current in a profile similar to your laptop here, what that's going to do is it's going to all add up, and it's all going to be trying to get power only when the voltage is at a peak, and you'll see it flat topping and pulling down more and more. But now let's say you feel like you've got a power supply, you got an issue, you're not delivering enough power from AC main. So you call an electrician, he comes out, he sticks his meter in the wall, he says, oh, but I'm measuring 110 or 115. And that may be true, but what he's measuring is the RMS value, and we're not seeing the full picture, which is the impact of your supply being insufficient or your load being too great only at that one part of the voltage waveform. The RMS value may be 110 or 115, but where it's trying to pull power has actually been reduced by a much greater proportion because the peak has now been brought down, say 10, 20 volts or whatever.
All right, no, that's a great point. So what is the remedy? If one of our dealers, one of our users out here, see that issue, they use their enVision tool, they see that they've got a high peak current draw and it's bringing down. What are some of the remedies that they can do?
Well, the first thing I would do would be to look at, split the load, balance the load. If you have another circuit available, move things to the other circuit. You could install a new circuit. You could install a larger circuit, like install a 30 amp service or whatever, a 30 amp whip, then you can split it off and to power all your small gear. If none of those are practical, you could, maybe in some cases, you could consider adding some sort of like a UPS or voltage regulator to regenerate the sine wave if all the power ratings will work with your equipment.
Yeah. I think
that's pretty much it.
Tips. Yeah. And sometimes what I will suggest that they do is if they can't get a 30 amp service in there, because that will require a different kind of plug, is just to at least increase the wire size, if that's at all a possibility. So yeah, these are all great tips, and again, they are driven by the fact that you guys have the data to see what the problem is, and that's what the enVision tool is all about. All right, so let's Rob, we want to be aware of time, so let's kind of quickly go through the rest of this because we want to get to the analysis phase as well. So this is the chart mode. You want to talk about this a little bit?
Yes, this is basically the same thing as the first mode that Vince showed you, where you had the green bars going back and forth, except now the data is being stored across time. See, Vince, if you could zoom in on the end of that, it's you can see where it started at the beginning. Then you've got that dead period, or restart the software maybe, just so we can see it updating at the very end. So all of those measurements, like right now, what's happening every 1 second. It gets the measurement at that second, right? That's the measured value right now, and it stores that, and then it captures it again the next second and the next second, right? And right now, when you're running this real-time chart mode, you can see how it would trend. And I always say, maybe if you have some potentially troubled equipment or defective equipment, go to the site, put the enVision on with your laptop, running this real-time chart mode, and collect data while you're doing other things or loading the equipment or cycling it or exercising it. And then you can go back and look for trends. And right now, the big thing to note about this is this data right now only exists in the computer's memory. So if you don't save it to a file, it's going to be lost when you close the software. This is different from the setting that Vince mentioned earlier to enable the internal chart mode. If the internal chart mode is enabled, this same set of parameters you see listed on the right-hand side will automatically be stored by enVision in its internal memory, but once every 10 seconds. And that's separate and independent of the other data logging, including this real-time chart mode. And that the internal memory could store that stuff, a fixed interval of 10 seconds for about 2.25 days.
Yeah. Okay. So we kind of glossed over this, but it's an important fact that the parameters that we are storing, of course, the AC line voltage, the current is right here, the wattage of the load, and again, that's because I've got my my computer power supply in here. Neutral to ground voltage, we can see over time, even though that the neutral to ground voltage is shown, that the units and the value is shown here, it's actually down here because we had we have to kind of calibrate it to get on the scale, to get on a common scale. Here's your frequency and your power factor and your crest factor.
And when you save this to a file, it'll dump it to a comma-separated CSV file, and you can open that right up in Excel and do whatever plotting and graphing and manipulation you want to with the data at that point too. Yeah.
So as you can see, since I pressed the start button of the chart mode, this is when I first pressed the button. As you can see, there was some variations in some of the factors. The power factor kind of jumped around, and that's actually a question that I get a lot at times when I should have covered it when we were on this. Guys will say, hey, my power factor is all over the place. Well, if there's nothing plugged in, the power factor will go all over the place because the tool just doesn't know what it's measuring because there's no load on it. But the fact that the power factor moves around is somewhat normal, and you shouldn't have to worry about it. All right. So continuing on, the next button here is a convenient button if you have the Rpip connected to it and you're accessing the device remotely. And from this, I can turn the outlets off or perform a power cycle, and then of course turn it back on. But again, this is just kind of a remote control if you happen to have something on the output of the enVision tool. The next button down here at the bottom is our data button, and of course, this is where I told you before you could erase the internal data that's stored inside the enVision. And of course, this is where you import the data from and download the data. The timestamp data is, of course, your power disturbances in chart form. And when you look at that, actually here is when you download it, we put the power disturbances or the timestamp data in this tablature form in a nice report ready form, so that you can you can present that to your customer or look at it yourself. You can also download it in in CSV format and look at it as far as in an Excel file. All right, and then of course your data here. So what I want to do at this point is go over and start looking at some data. Let me get over.
And Vince, if I may, the reason why the kind of overview timestamp summary is a formatted PDF report is we found that a lot of times that kind of formatted report looking summary is very helpful when you're dealing with an electrician or utility or facilities management, to show them, so they're not looking at this data is very useful, but these guys may not be very technical, so they don't have to look at a spreadsheet full of numbers or look at graphs or plots or anything. They can kind of look at the summary and say, okay, I believe you, there is a power problem, and we'll go investigate it.
And Rob, I think you make a great point. There's something believable when the report looks official and it has a company logo on it and all that, and they're looking at numbers on a spreadsheet. It's not as believable as if you get an actual report. So great. So Jimmy, I want to we're going to start on the analysis and the interpretation side, and I want to bring Jimmy in. Jimmy does quite a bit of analysis for his dealers. I want to remind you guys that although we are presenting this information to you, do not hesitate to allow us to assist you to analyze this data. We're going to be going over kind of just a broad stroke over it, but the more you dig into this data, the more you can get out of it, and we've got a lot of experience doing that. So please don't hesitate to call us in. But when you pull the historical data, it's a CSV file, and it looks very much like this. And of course, to get it on this landscape screen here, I can only get 25 lines in. The Excel file, might have 6,000, 7,000 lines of data, and you can manipulate it. And one of the first things that Jimmy taught me to do, I think it's a pretty cool idea, is to use the mathematical functions within Excel and create a new column where you're looking at the voltage swings. Just to back up for a second, the way that the historical data works, the instant that you plug the enVision tool in, a 30-minute time window starts. And at the end of that 30-minute window, and actually at the end of every successive 30-minute window, all of these parameters are stored: the average power, the max power, the average voltage, the max voltage, the min voltage, and the max current draw that was observed during that 30-minute period. Okay, so what this allows us to do is to.
Vince, if I can just kind of chime in on that, the way that we determine all of this stuff within that 30-minute window is we have new measurements every 3 AC cycles. So that's basically our RMS calculation window is 3 AC cycles. Then with every 3 cycles, we get the new measurements, and then we say, okay, is this measurement greater than the previous maximum or smaller than the previous minimum, and then update those registers. And then we also add on to our accumulator to do the average measurement sort of thing. So we're actually looking at these values really, really frequently and updating them, and then we just log them every 30 minutes, like Vince said.
Excellent. And it's a great way of compressing the data. If you can imagine, if you were storing data every 3 AC cycles, remember, 60 hertz means 60 cycles per second. So, that would have been, you divide that by 3 cycles, that would have been every second having, 20 times the, 5 or 6 values it would be a huge amount of data, right? So this is a way to kind of compress the data and still having it be very, very useful data. So anyway, what he likes to do is do the the maximum minus the minimum, and we get this voltage swing. And once you get the voltage swing, which is the difference between the max and the min for any 30-minute period, we can sort the data to see, hey, where are all the high voltage swings? And as you can see from this data set right here, that at different times, sometimes the minimum voltage went down to 0. That means we had a power outage. But sometimes, as you can see down down at the bottom of the page, the voltage swings don't go down to 0.
And and the reason we're looking at this is, what does that mean? If your voltage tends to be pretty stable, your average, your max, and min are all roughly close to the same value. Well, that means that your supply is adequate for the load, and nothing weird appears to be going on. If your voltage frequently is low, like your minimum voltage is below some threshold, there's some guidelines out there from utilities and the NEC, then that could mean various things. And if your voltage is regularly higher than some other threshold, then that could mean something different. And if you tend to notice like a wide swing in here between your maximum and minimum measured values in a given 30-minute window, well, that's a strong indicator of something else also. So that's why kind of these measurements are really valuable. And the voltage is kind of the first place where we look, because it is kind of the biggest barometer for your overall AC system's health, if you will, which is why, when Vince said earlier, you get a lot of data out of the enVision, even if you don't connect it in line with the load. If you just plug it into a shared outlet or something and have it record the voltage, that gives you a lot of data. Now, of course, you get a lot more data if you connect your gear through it, so it actually measures the current and the power draw and all that stuff, and then you can draw even more conclusions. But the voltage itself is a great place to start. Sorry for hijacking you, Vince.
Oh, no, that's great. So usually when I'm doing an analysis of this, I'll start and I'll do that voltage swing column. I will put it in order of maximum to minimum, and I'll page down and see where the voltage swing starts to get below 10. It's like to me, if you've got a 10-volt swing, within a 30-minute window, it's like, well, there's something going on there. And sometimes that 10-volt swing is still within, ANSI standard regulations, right? It's still between, the 110 and 124. That's a 14-volt swing. So you could have a 10-volt swing and still be within spec. But the fact that it is moving, and actually that kind of leads to my next graph right here, is I'll do a histogram of, how many times it hits in a 30-minute window in these specific categories. So remember, our target voltage is basically 120 volts, and you can see on the minimum side, for this particular data set, 1,245 times it hit that number, and on the maximum side it was 735. But you can see the distribution of how many times in a 30-minute window the minimum or the maximum was not inside our window. And this is an indication that, you've got a voltage fluctuation issue, and, it needs to be remediated either by, looking at to see if, if the wire size is not sized correctly, and Rob, that leads us to this particular example. I think this is a good example. If you want to talk about this is a loose neutral example.
Right. Yeah, and you see the data here, Vince. Any chance you could switch to my screen? I can kind of show what it looks like when you're looking at the historical data in the enVision software.
Actually, I think that Rob Nelson needs to switch it over to you.
Okay. Well, either way, I can talk about it. And you would the maximum and minimum as different colored lines in the enVision software. So you could kind of, I like to look at it visually, and I just look at the max and min. And in this case, with this particular data set, which came from an equipment location and real field data back from in enVision. You'll see that they're pretty far apart. And in this case, on the low side, it was really regular, just almost every 30-minute interval. The minimum recorded voltage was around 113, 112, and the maximum was up in the high 120s. And now with a target of 120 volts, to me, that immediately says that there's a problem with your neutral conductor. And what's happening during those periods is you've got some equipment, like let's say it's a residence, and you've got a 120/240 center tap service, and you basically have the two 120 volt circuits coming off of the same transformer. Well, if the neutral connection is bad, either missing completely or just loose in a high impedance, what you'll see is stuff like you turn on heavy loads, and you might see like lights flicker, weird things like that, and basically the voltage will start dividing itself differently between the two circuits, where sometimes it's going to be higher on circuit A while it's lower on B, and then if the loading changes, now it'll be lower on A and higher on B, that sort of thing. So we see enVision was on one of those circuits, and it was swinging all over the place, high and low, which tells me that you probably have a loose screw somewhere in the breaker panel on a neutral bus or something like that. And this data really points to that.
Yeah. And Jimmy, you can probably speak to this. How many times has our enVision data allowed us to help a customer improve the power quality through the infrastructure of the network, not just by adding equipment. Adding equipment is one way to improve it, but sometimes it's infrastructure changes that we talk to them about.
Yeah, I think daily now. I talk to dealers for sure, and about every day to every 3 days we get another new enVision log to look at. I've started collecting these enVision logs for the past year and a half roughly. We have well over 100 plus dealers worth of enVision data from all over the country. And the one thing, I just mentioned this in a dealer meeting near Seattle yesterday, the one thing that I'm noticing as more and more of these logs come in from all over the US, the instability of the grid is definitely something that our customers seem to be beholden to. And it's the fluctuation in voltage that I find seems to be the biggest nuisance. And you're right, a lot of times we are able to help the customer get to the root cause, which might be wiring within the structure, or if we've had an EC confirm wiring is has its integrity, we've got tight connections everywhere, we're not missing ground, we've got bonded neutrals that are proper. We're finding that it's the utility. We've had corroded transformers, we've had loose neutrals in the transformers. Then here our integrator is being held feet to the fire because guess what? It's his or hers audio video product, those devices in the system that don't seem to be working. So it's been huge. It's been from minor to very major, getting customers out of actual litigation. So it's been pretty big.
Yeah, no, and I agree. I think for me, the biggest eye opener, Jimmy's been with Surgex, much longer than I have, and I have been, looking at these enVision logs. What's really interesting to me is to see if the enVision data is more than about 50 or 60 days, and sometimes we get data that's only 30 days old and it doesn't have a lot of historical content in there, of course. But if it's more than 50 or 60 days, invariably there is some kind of voltage variation in that data set, and it's like it really is an eye opener to see. We take for granted that the voltage coming out of the wall is 120 volts, and boy, it varies. It varies a lot, and it's not until you look at these enVision logs to see it. This is an extreme data set that we're seeing here, that it's going from the 112, 113s up to 130 swing every 30 minutes. A lot of times I'll get a data set where 80% of the data set or 70% of the data set, the differential between min and max is only 1 or 2 volts. It's like, all right, that's a pretty stable. I mean, how many times, Jimmy, have I written in the report? When it's good, it's really good. But boy, when it's bad, it's really bad. Because these voltage conditions can change at any moment. Again, and it kind of points to the point that I made earlier, that voltage is created real time. And just because it was good, a second ago, doesn't mean that it's going to be good 5 minutes from now. Because they're always having to reprove themselves. So I think we want to end up here, Jimmy, with I think you wanted to talk about this slide here.
Yeah, often when I get word back from a dealer, we've had a chance to review the logs. Vince, you've done so many reviews. We've even pulled Robert Dolly in on the really big ones just to make sure we've crossed our T's and dotted our I's and know a little bit more about what we're tackling. But I guess in general, customers, integrators will ask, well, what can we do to try to mitigate for a lot of these issues? We'd love to fix the actual problem. And most of the summaries we give back to the integrator revolve around, let's try to address the problem globally for the whole structure, the job site, by tackling the electrical wiring, if we think that might be the root cause. And again, if it seems to be integral, then okay, let's try going over to the utility and making sure we don't have an input issue from the service. But in general, if what we're really interested in protecting and making sure that the experience to the end user is top notch, is a great experience, then what I generally say, and Vince has done a great job of providing an illustration to the point, we want surge elimination ahead of an online dual conversion UPS. And we want some level of control of power, whether it's an IP addressable product from Surgex, Snap AV, Middle Atlantic, Pack Edge, Luxel, Blue Bolt, you name it. But use some sort of level of control, but don't just use the IP addressable product. Don't just continue to react to issues where products need to be rebooted. Try to figure out why they're being rebooted, and then to ensure that you reboot less. If you put surge elimination at the wall outlet, and then you bring in clean and stable power, the two critical benefits to an online dual conversion UPS, stability of power being number one, and then power with no interruption, no transfer time to battery if in the event of a power outage or a severe undervoltage or overvoltage, we need to continue to supply stable power to the very sensitive equipment in the IP addressable power product. If we are able to provide that surge elimination without ground contamination, clean and stable power without interruption over to the sensitive devices, guess what? We'll have way fewer issues in the field. And then as you see in the illustration, we've utilized enVision, and we're keeping enVision on the site. And the real reason for that is if you have an issue next month, 6 months from now, do you really want to start then and trying to figure out what the cause of the issue is? Or would you rather be able to assess immediately, was it power related? Question mark. Let's go check the logs. Let's see if last weekend, last week, last month, this last 6 months, we had a pattern of power anomalies or events that might have caused the actual issue with the product.
Those are all great points, Jimmy. I tell the guys I talk to every day the same thing. It would be wonderful if you came on the job site and the first thing you did, you either rule in or you rule out power as the issue. That's really the power of this enVision tool. So do we have any questions out there that we want to address? All right. Well, I want to thank everybody for their time today. As you can see, the enVision is a great tool to help you either rule in or rule out power as the root cause of the system issues. And it may be the evidence you need to prove that your system problems are due to power company problems and not your equipment. So thanks everyone for spending time with us. Jimmy, thank you for your time. Rob, for your time as well. The Power Hour is brought to you on the third Thursday of every month by SurgeX. Our next Power Hour on February 21st, powering up the end users, why advanced power protection matters. In this webinar, we're going to talk about ways for you to talk about power protection to your customers, because at the end of the day, when you're adding comprehensive elite power protection like you get from SurgeX, sometimes you need the ammunition to be able to talk about that. So we're going to arm you with those with that information, and also remember that our previous Power Hour webinars are available online, but not at that location that's right there. We have moved it to a different one, and I forgot to change it on this slide. But please contact your representative to get the link to this and other webinars. So thank you very much.
Yeah, thank you.